Okay, this is the introduction for lab number 2, and it's going to be measuring speed. And it's actually one of the few labs where it's not an online simulation, and you need some of your own materials. So what we're going to do is we're going to measure how fast we walk. We're going to measure our walking speed. So what we're going to do is the first thing we're going to do is we're going to make a prediction. So you're going to make a prediction of your walking speed. Now, one thing about the predictions is I don't grade them for accuracy. If you think that you walk 50 miles per hour, then that's perfectly fine. I only grade predictions on whether you actually put some ink on the paper or not. So they can ask me of your walking speed, and give me an idea why. And then what you're going to do is you need to have a ruler or a tape measure. And in the lab I use meter sticks, but if you just have a regular yardstick or something like that, that is perfectly fine. You can work in feet. You need a stopwatch or a timing app on your phone, and just something to mark your position, like some chalk, some tape, or pretty much anything. So what we're going to do is, if I were you, I would mark myself off a track, and so I would put a line right here, and I put a line right here, maybe about 10 feet apart or so, and I would go ahead and I would measure that distance. And then what I would do is I would also measure the time, and something I know is that my speed is going to be equal to my distance divided by my time. So if I measure the distance and I measured the time, then I should be able to calculate the speed. Now, one thing to kind of pay attention, so here we have, when you actually calculate your speed, if speed is going to be equal to distance divided by time, pay attention to your units. If the unit for distance is in feet and the distance for time is in seconds, then your answer should have units of feet per second. What we're going to do next is we're going to go ahead and we're going to convert that into miles per hour. So let's talk a little bit about how we're going to do that. Now, most people need a little bit of help with this, so this hopefully should help you. Suppose I measured my speed, and in the lab I might have measured it at 2 meters per second, and I want to convert that to miles per hour. What I would do is I would say, well, I want to get rid of that meter, and I want to get rid of that second. So there's my 2 meters per second. I want to get rid of meters, so I'm going to essentially multiply this thing by 1, and I'm going to say, well, I know I can convert a meter to a mile, so if I go ahead and I look that up, it turns out that it's 1609 meters per mile. Now, what I can do is I can go ahead and explicitly cancel off my units right there, and if I were to divide 2 by 1609, I would have my answer in miles per second. But I don't want it in miles per second, I want it in miles per hour. I want to get rid of this seconds, so I'm going to put a second right up here, and I'm going to put an hour right down there. I know that 1 hour has 60 minutes, and there are 60 seconds in a minute, so 60 times 60 is 3600. And if I were to go ahead and type into my calculator 2 divided by 1609 times 3600, then what's going to happen, I'm going to cancel out my seconds, is I'm going to have my answer, and that answer is going to be in miles per hour, the units that is left over. You go ahead and you type that into your calculator, and you're going to get 4.5 miles per hour. Now, you can use Google to check your result, but at the end of the day, I explicitly want to see this cancellation of units because you are going to do that a couple times throughout the semester. So here we are back at the lab, and again, please explicitly show your cancellation of units. And does that agree with your prediction? And maybe it does, maybe it doesn't. It's always good to make a prediction and see whether you're right or wrong. Now, we're going to collect some more data, and now I'm going to ask the question, was my speed constant when I did that? And the answer to that one is actually, I have no idea whatsoever. I did not measure that, and in my observation, most people don't walk at a constant speed. They start at rest at the line, and then they speed up as they go. So if this was the track that we had before, what we're going to do is we're going to see if the speed really is a constant. So what I would do is if I were you, is I would put a couple dashes in right over here, so put some more marks in there. What we can do is we can use the lap function on your phone to kind of measure your time at all these various positions. So here I have my distance, and here I have my time. So for each of these intervals, I can calculate my speed. Same thing, speed is going to be equal to distance divided by time, and see whether it really was a constant or not. So we can see whether it was or was not constant. The last thing we're going to do is we're going to graph our walking data of our distance versus time. So here we're going to have our distance, and you're going to put some numbers all the way down here, and you're going to go ahead and put your data points on there for all your various distances and all your various times, and does it fall in a straight line? So let's talk about that for a second. Something that I know is that the position versus time, if it were to, say, look kind of like this, and if I could fit a straight line to it, what that actually means is I'm going at a constant velocity. I'm covering the same amount of distance as time goes on, within my ability to draw these poor straight lines. Now, the slope of the position versus time is going to actually be the velocity, and that should be a straight line within my ability to measure. And you can kind of see the slope there is the same, the slope there is the same, and the slope there is the same. Now, this guy actually has no slope, it has a slope of 0, and the slope of the velocity versus time is actually the acceleration, and that kind of makes sense. This thing is moving at a constant velocity, and what that means is no acceleration. What would these graphs look like if I were speeding up? So I'm going to say, well, what would happen if I actually had some acceleration? Then what would happen is my speed would be increasing. That's the definition of acceleration, would be a change in velocity. And this guy would go up just like that. And my position versus time, I would be covering more and more and more distance as time went on. So now we're going to come back right over here, and does it fall in a straight line? Well, what does that tell you about the motion of the walker? And I do have you calculate the slope. Again, the slope is going to be the rise over the run. So this guy right over there is going to be my run, and if I were to go ahead and scroll up right over here, this is going to be my rise, and that's the definition of the slope of a line. And you can pick those guys off of your data, and you can calculate your work, and what does this really mean?